Allah ya Allah, Allah ya Allah.
Assalamualaikum warahmatullahi wabarakatuh. I welcome you all to the second module of Digital Logic Design. In the earlier module, we had begun with the digital logic design. We studied what is the digital logic design and how we saw an example of the voltage, how the voltage can be represented using the analog signals or the digital signals. We studied like there are so many various appliances that we use day to day in our life that is very much essential for where we are going to use the circuits, and that is going to play a very important role. And we studied like we have home appliances, kitchen appliances, almost all of the electrical appliances that we use, they use the digital circuits. And today we are very well aware and we live in a society where we are very much going to use the electronic device. Everywhere where you are going to have the electronic device, it is necessary that we should have circuits. Circuits are very much necessary in order to study how they are made the connection, how the electricity pass through them, what are the various other chips or any other electric components that are required so that the electronic devices function properly. There we saw the various things that is necessary, and since we are into the IT course, definitely we are going towards more and more towards the IT devices. And we studied like yesterday in the previous module that we are having the devices, the electronic devices which are using the digital circuits and how the voltage or the current is going to flow through them. And then we studied about the components such as like how the digital data is being stored, how it will be moved, how it will be processed, and how the output is going to display. So we shall, inshallah, in the today's module we are going to continue with the previous concepts. Along with that, how the things we are going to take further. So previously in the last module we just started with the discussion about the digital computer. As I said, we are into the IT, we will go towards the IT devices more than the home or electric appliances. Nowadays, everywhere, in every home, every place, we see that we need the digital computers. We can see the computers being used for almost all of the purposes. And we are going to see in detail how this digital, what is the block diagram of this digital computer, how there is a communication occurring between the different sort of devices. And here is the block diagram of a digital computer. In the previous module we had discussed this, but here inshallah once again we are going to just revise what is this concept about the digital computer, and we shall move on further. As you can see on the screen, there we are having totally 4 units. The block diagram of the computer has been divided into the 4 units, and in case if we club the 2 things at a time, then we are going to have the 3 main components or the main units of the digital computer. Firstly, we are having the input and the output. This is an essential part of any computer. Why we require this input and output? Input is used to accept or read some data from the computer, because computer, if you just talk in general terms, it is a machine which does not have any brain. It cannot use its own senses. It doesn't do anything on its own until a human gives some command to it. So when a human gives command to this computer, it has to read what is the instruction that has been given from the human. So in order to read these instructions or this input, we have the input devices where the computer will take all the input from the user. And especially we have the devices such as that of a keyboard, a very common example which almost all of us use every day. That is a keyboard. Like suppose if you are logging into any sites, or if you want to open any pages or something, we need a keyboard and we need to type the URL. Suppose if you are opening a Islamic Online University webpage, we need to say the computer is just blank. It is never going to understand by its own what is the thing that is required by the human. At that time, as a human, we need to enter that we want to enter or we want to open the pages of the Islamic Online University. So I just give the input. I have to provide the input, and that input is being provided with the help of a keyboard. And there are some many other examples of input, like as I'm speaking, the speaking is done with the help of a mic. Now here this mic, it is going to take my voice and it is giving it as an input and it is being stored. Now this is also one of an input device. So there are various devices, we can classify them. And then next we are going to study about the output. Once we gave the input or some instruction to the system, now after it has processed, we should get an appropriate output of that whatever has been computed. So in order to get the output from the system, we require a proper interface where the human, once it gives the input, it should get the response back from the system or the digital computer. So for that we are having output devices. Though we are having many varieties of output devices, a simple one is your computer screen, as what you're seeing there. That is what is our output. Something I'm saying here and you can see it and hear it there or on the other end. So this is an input, and what you're seeing on the screen is your output screen. Now this is what is an example of an output. In between that, whenever a user gives something command and before it has been processed and before the output has been given, there we require something to be processed, something that has to be computed, something that has to be read and understood by the computer or the system. So for that we are having the two units. One is called as the control unit, another one is called as a data path. Now what is this control unit and the data path? Now once we there suppose if I want to add a sum of three numbers. Now if I want to find the sum of three numbers, I'll add 1, 2 and 3. Now if I want to add this number, when I give the input as add 1, 2, 3, these three numbers, they have to be first stored into the memory. They have to be first stored into the memory. So for that we require this unit, which you can see on the board on your screen. This unit is called as a memory unit, where it is going to store the data or the input whatever the user has fed into the system, because it can't remember. Unlike we have the brain, we have some memory. Like that, even the system, it has some memory where it will store that information. So when we are giving an input to the system, it is going to store all those values, 1, 2, 3, whatever input we are providing, that needs to be stored into the system's memory. That will be stored there. And then once, if like I'm performing some operations, I'm performing addition of three numbers. So addition of three numbers, what it does, for that we have an option called as a data path. This data path, what it does is, it will take the input and which is stored into the memory. It performs the appropriate operations that has been mentioned. So the operations that has been mentioned is nothing but addition of the three numbers. So first it will take the first two numbers, because at a time it can add only two. It will take the two numbers, that is 1 and 2. It will perform the addition, and then the intermediate result 1 plus 2 is 3. That has to be stored once again. So this intermediate results will be stored. It will be sent back once again to the memory. So this memory, it will just store the intermediate result, and then after that again it has to add the another two numbers, that is 3 plus 3. Once again this data will be read from the memory and it will be given to the data path, where we are going to specify what operation it is going to perform, and these operations, they are nothing but addition. So this program has been stored into this data path. So again the two numbers, that is 3 and 3, will be once again added, and the final result is 6, which is going to be stored back into the memory. So again, after performing the addition of these numbers, the data will be once again stored back into the memory, where it is going to store the data values, and after finishing that it will be sent back to the data path, and once the result has been stored it has to be given to the user, and that will be once again displayed onto the output screen. So when the user gave the input, it went to the data path, it went to the memory where it got stored. From the memory it stored to it was given to the data path, it made the computation, it gave back the intermediate result to the memory, again the memory gave the two more numbers, again it performed the operation, again it went back to the memory where the final answer was stored, and from there the output was being displayed onto the output screen. So this was the process that was involved. Now these were the three functions of the input, the output, the data part, and then the memory. And if you see, there is one more unit called as a control unit. The control unit, what does it do? Control, as the name itself indicates, control. It is the one who's going to control all the other devices that has been attached to this digital in the entire system. So it has to look after all the devices that are present. So the control unit, its task is to have supervise the memory, the data path, the input and output, all it has to coordinate. Just if you see, there is a direct connection from control unit to the memory, there is control unit from connection from control unit to the data part, from the control unit to the input and output. So everywhere has been controlled by the control unit. And now when we combine this control unit and the data part together, that is the data part's task is to perform the operation. Obviously, whatever operations the user wants to perform, calculation or any other part of the operations that has to be done, when we club this data part and the control unit together into a single unit, that becomes our CPU, that is called as our central processing unit. Now the central processing unit, it is said to be the heart and brain of the system, because it is going to control and look after that each operations, whatever the user is asking to be done, they have been conducted very smoothly and efficiently. For that we are having this control unit, or that is said to be the central processing unit. All this together, that is the control unit and the data part together, they make it as a CPU. So this is the whole and soul structure of the digital computer. Now the memory, as we saw, the memory, it stores the program as well as the input, output, and any other immediate or the intermediate results will be stored into the memory. And the task of the data path is it has to perform the arithmetic or any other data operation that is being specified by the program. Whatever operation, be it any arithmetic or any other data processing operation, if the user has specified, it is the task of the data part to perform those operations. Then we are having the control unit. The control unit, it supervises the flow of information between the various units. So it sees that whatever is the flow of information that is happening, first the input will be sent, from the input the data will be sent to the memory, from memory it has to be fetched and given to the data part, the data part performs some operations, it gives back some result to the memory, and the memory gives the result back to the output devices. So there are various operations that has to be taken care of, like there are various devices being used like input, output, memory, as well as the data path. So all these operations, all these units have to be clubbed and they have to be supervised, and for that we have the control unit who supervises the flow of information that is happening between the various units. And then we are having a data part. That is, a data part, when it is combined with the control unit, it forms what is called as a central processing unit, and in short we are going to refer it by the name CPU. CPU stands for central processing unit. The program and data prepared by the users are are transferred into the memory by the means of an input devices such as a keyboard. So when we are having this program and data, whatever the user has prepared, it will be transferred to the memory by the means of an input devices which has been called as an keyboard. And we are having an output device like such as that of an LCD screen, that is a liquid crystal display. The result of the computation or any other information that has been processed and that has been demanded by the user has to be given to the user, and that output will be displayed on the LCD screen. And then we are having a digital computer. A digital computer, it can accommodate many different input and output devices such as DVD drives, a USB flash drive, a scanner, a printer. We know that a DVD drive where we can insert the CDs and then the DVDs. A CD from where a data can be read, or it is the place where the data can be put. Like suppose if I want to read some specific files which is there written on the CD or the DVD, I can read it. For that we need a DVD drive being attached to the digital computer. Or sometimes if I want to take a backup of all my files and store very important files, because I doubt my system, it may crash. For that I will take a backup of my data, so I may put that in the CD and the DVD. For that I need a DVD drives, or also I can take it in a flash USB, that is a USB flash drives or your pen drives, where you insert it and then take a backup or read the data from these drives. And then we have a scanner. A scanner is also called as an input device. It is called as an input device because from there we are going to read some data. It scans some of the data like any hard copies. It will scan it, it will read it like in a form of image, and that will be presented as a data. And then we have a printer, which is nothing but an output device, because from the printer we are going to read the data, or from the printer we are going to have the as an hard copy. We can say that suppose if the user is want to take a print of the notes, he will take and he will give the option as print. So the output is coming here, like not in a form of electronic but in a form of a paper or an hard copy. So that can be acted as a output device. Then these all devices, like we discussed so many devices, these all devices, be it a scanner, a printer, or disk drives, or a LCD, or a keyboard, or a mouse, or a joystick, all these various devices, these all use a digital logic circuits, but they often include an electronic circuits, optical sensors, LCDs, and electromechanical components. This digital logic circuit, it is common for all the devices, and depending on what kind of device we are using, some may use analog signal, some may use electromechanical components, some may use logical sensors, and some may use some other LCD screen. So depending on what instrument you are using, it differs. Like we discussed about the DVD drives, it contains an electromechanical device on which we are going to put the CD or the DVDs, and once we are going to put that CD or DVD, it is having an electromechanical spindle where the disc is going to be rotated again and again to read or write the data from a specific path. This is one thing. And we are having the mouse. The mouse is nothing but it is an optical sensor. It is called as an optical sensor because if I move the mouse towards the left, towards the right, towards the top or bottom, this sensor will sense and it will read what value or where I am going to coordinate the points. So that is going to read some of the places. Similarly, some devices may have an analog electric circuits. Like I am speaking in the mic, it may take my voice in an analog form, convert that before storing it into the computer system, before storing it into the laptop. It has to convert this analog signal into an appropriate digital information. This information analog, sometimes my voice may be louder, sometimes it may be slow. So this variations, that is the frequency, will be noted, and this will be in the form of analog signal. Once the analog signal is there, it will be once again converted back into a digital format. So be it whatever devices we are using, the digital logic circuit is common for every electronic device, and some other devices, depending on what device we are using, they may vary with the electronic circuits, with the optical sensors, with the LCDs, and then with the electromechanical components.